Hello, am I audible?
Yes.
Hey Tanvi.
Playing Mini. Hey everyone.
Hey Sunny, thanks for joining.
Hello, Sunny.
We are just waiting for one more team member. She just connected and some problem was there. So she'll connect again. Just give us a
Okay.
few minutes.
Sure.
Thank you.
So you all guys are in like Vishnu's class?
Yes.
Okay.
Yeah, we are doing our master's in data analytics. So this one is for our big data subject, actually.
Okay.
I guess Tanvi is here.
So as I said, thank you for joining with us. It's really great to have you, and you're sharing your valuable time with us for this interview. We are doing this for our big data project assignment. And we are group one, and myself, Priya, alongside with me, I have four other team members, Riddhi, Ravina, Saujanya, and Tanvi. And let's start we would like to get more about yourself. We have seen your LinkedIn profile. So please tell us about yourself and your experience to start with.
Yeah, let me give you a little bit background and let me know if I'm going too long, okay? I like to talk about myself at times. So I'm a senior sales engineer with Snowflake. It's been nearly like fourth year running with Snowflake. Joined as a resident solution architect, helping with customer onboarding, and the customer strategic onboarding to the platform of Snowflake, migrating from legacy systems, you name it, like Oracle, Teradata, SAP, the Hadoop platforms of the world into Snowflake. So I covered a lot of strategic Cap 1 accounts. We call bigger organizations with more than 10,000 people organizations as Cap 1 accounts. And then last 1.5 years moved into sales side, covering again Cap 1 accounts, working with the bigger customers on a broader strategy in terms of how they can leverage the Snowflake Data Cloud platform and get much more richer insights and get fully unlocked from the platform capabilities perspective. Prior to Snowflake, spent around 12 plus years at Cisco in multiple teams. I do come from the engineering background, from the days of writing code in Oracle, going into ERP, Business Analytics Center, played a role for a business operations manager for a couple of years at Cisco in supply chain, logistics, and operations team. And then towards the later half of my time at Cisco, I was handling data analytics groups, leading the data transformation for a group called Data and Analytics Center. And that group was kind of responsible for all things data that Cisco works with. You know, if there are numbers that are going out on the street on the financial matrices, our teams were responsible for producing those numbers. So kind of removing the data silos and kind of putting a data gravity towards the centralized data solutions.
Thank you, Sunny. So let's move on with our interview questions. So we would like to start with Hadoop and MapReduce because that's our first syllabus topic. I know you have some experience with it. Can you share like your experience with Hadoop or MapReduce or something when you worked? Or you can say like how it has been evolved or been integrated into your current experience in Snowflake.
Yeah, I'll start with sharing a kind of a quick story around that topic. I believe 2016, 2017, I was at Gartner's and an interesting metrics came up on Hadoop. So we were using Hadoop at Cisco. We had the world's largest MapR installation. If you don't know, there are like providers for the environment. MapR was one of them. Cloudera is another one. So Cisco adopted MapR solution for their Hadoop strategy. So we were using that platform, but we went to Gartner's and Gartner shared a very important metrics with us in 2017 time, if my memory serves right. And they said Hadoop has been there for now a decade by 2017, and only 14% of the use cases are actually in customers' production environment. And that tells a kind of a different narrative, right? Hadoop was kind of a replacement for a cheap storage rather than some things that the organizations or enterprises look for in order for the enablement. So not too many data applications were getting installed, but it kind of served its purpose when it got first kind of brought into the realm of the big data cloud story, right? Which were the three vectors things that we talk about: high availability, velocity, and agility in doing things, and eventual consistency that we talked about. Later on, the big players, the cloud service providers, namely Azure, AWS, and Google, kind of filled that void in terms of providing the cheaper storage as we know of today, the S3s and the blob storages. And then the MapR kind of filled in for the MapReduce. Those things are now available as the services that these CSPs, the cloud service providers, provide in terms of the EMRs, right? Like Elastic MapReduce kind of a capability. So we do have a synonymous tech stack available, but the things have kind of greatly evolved from the era and the time that Hadoop introduced on us, bringing in the cheaper storage, because not everybody wants to pay like $1,500 per terabyte to the words of Oracle, right, for storage capacities. But now we have kind of moved on to an environment where the storage is kind of a very negligible or minuscule part of the entire data ecosystem. You are like looking at like $23 of a compressed terabyte or a cheaper storage that is made available by majority of these cloud providers, depending upon how the negotiations actually goes with the enterprises. But like the world has evolved. The world has moved leaps and bounds in terms of what it does now versus a decade before in terms of handling the big data from the genesis of the kind of a verbiage that was thrown out to the world, right? A big table, big data, lots of information that was thrown into a kind of a data lake strategies, and then we have evolved from that point onwards.
Thank you, Sunny. I would like to hand over this to my other teammates so they can ask a couple of questions from you.
Yeah, and feel free to jump me in if you want to double click on anything that I'm saying.
No,
Feel free.
that is like
Yeah.
great to know how it has been evolved. Thank you so much for the detailed explanation.
Hi, Sunny. It's Riddhi here. First
Yeah.
of all, thanks for your valuable time and sharing your expertise with us. So, my question is, how are data pipelines built in Snowflake? I mean, can you explain how it works in real time?
Oh yeah. Are you familiar with the Snowflake architecture by any means, or do you
Not
want me
that
to
much.
start from? Okay.
Mm,
So let me see if I can pull up a kind of a quick slide. And again, I get carried away times. Feel free to stop me at any
No, no,
point.
Yeah.
please take your time. We would
No,
Yeah.
like,
I'm just saying because all I do is talk,
Yeah.
Uh,
we
so
are
let me,
we are like here to learn, and anything
Yeah,
from
okay.
exactly.
these are like valuable information for us. So please, yeah.
For some reason, I'm not able to share my screen, but it says host disabled screen sharing if you want.
Aditi?
Yeah, let me see. Now you can share the screen, I guess.
Okay. Let me see. Okay. So I went into docs.snowflake.com, right? It's my go-to living place day in, day out, you know. And I can get to a lot of these things, and let me try to see if I can pull up a architecture slide. So Snowflake changed the dynamics of how we perceived distributed computing, you know. So coming from Oracle world, I would say these are like bundled system processors, right? Like
Mm,
if you would get an Oracle instance, it will come with a specified number of storage, RAM as a combination. It's a kind of a laptop that is pre-configured for you, right?
I see.
So you cannot change the CPU once you bought the laptop, right? You can always say, hey, I want a i5 processor or i9 processor or i7 processor and with some storage, right? So
Yeah.
you are defining a pre-configured notion in the legacy world, like Oracles and Teradata. They give you a pre-configured things. I will give you these many CPUs to run your processes, this much amount of storage. Anytime they want to make some changes, they have to bring down the system, add storage or a Oracle in an Oracle rack, which is like
Mm-hmm.
clusters of CPUs and storage. So they have to bring down the system, make some changes, then bring up the system. Like you will literally have a kind of a shutdown of the entire things, and then you will bring it up with the newer configuration. Like
Oh,
shut down the laptop, add more RAM and power on the laptop. Similar strategy, right?
yeah.
Snowflake brought in a different dynamic into the whole equation of cloud computing. They brought in a concept as independent uh, layer for compute versus storage. So the storage is infinite, unlimited storage. So you whatever storage you need, you don't need to think about the capacity. You don't plan for it. You need 1 TB, you need 1 PB, or need 1 EB. Storage is available to you, and so
Okay.
are the compute resources. So what we
Mm-hmm.
call the compute nodes are something called as virtual warehouses. Consider these as EC2 machines for generalization. You have
Okay.
multiple elastic compute or multiple laptops. Consider it as a multiple laptops, right?
Yeah.
So this is one laptop with the horsepower of the CPU. This is another one, another one. What it does, which is beautiful, is multiple things can interact with the same storage because they're not tied up together. You can bring up warehouses, more warehouses, not only three, you can spin up 100 warehouses. You are all working on the same data at the same time. So in legacy world, if I was running a pipeline, and coming back to the question, right? If I'm running a finance pipeline
Mm.
and some marketing pipeline is running, there
Mm.
will be noisy neighbor concept. Noisy neighbor means there will be a scenario.
Sounds detected at your porch.
There will be a scenario where uh, finance jobs may get impacted because somebody is running another pipeline, because they're all sharing the resources, because you are
I
only
see.
given a finite number of resources.
Mm-hmm.
Snowflake changed that game. Snowflake said, if a data engineer is working on it, you can have data engineering warehouse. If the marketing team is running something, they can have their own independent warehouse and they can all run in parallel or at whatever time. And on top of that, we said, if you are not using a warehouse, you're not paying for it.
Okay.
But in Oracle world, it is all pre-configured. You use it or you don't want to use it. If you are using it under, you have overpaid. If your capacity increase, now you are confined with the number of resources, you know. So you have
Yeah.
already built a house with bricks and stones. There is very little flexibility around that, right? Because the house is built, whether two people are living or in a room or 10 people are living in the room. But with Snowflake, it says it is elastic. The room can grow and the number of rooms can be added. All that things can be added on the fly. Now, when the pipelines are created in these manner, right? The pipelines need resources, right? So you will build a pipeline as you would in any other system. If you have a pipeline that is built in Oracle, a similar pipeline can be executed given the syntactical mapping is there between all these platforms. Snowflake is built on ANSI SQL and more. So your ANSI SQL, like your SQL queries, your tables, databases, it's all similar concept in Snowflake. You will eventually build the pipelines in a similar manner in the platform also, in the Snowflake Data Cloud platform. But you are getting much more out of it. Your pipelines are not having any contention. They can run independently of other things that are happening. A business user can run a dashboard while you are also running a ETL. Now you can always argue between a concept saying, hey, is my data clean or something is happening? Those are all controlled because Snowflake supports ACID compliance, right? It will let you do all these DML, DDL changes onto the underlying objects that you have while you are building the pipelines, but the consumption can still happen, right? Business can continue to work in parallel while the pipelines are getting built. Now, from the perspective of data engineering, Snowflake supports lot many features from the data engineering perspective. A very recent feature that was included was something called as dynamic tables. Dynamic tables lets you create incremental pipelines and you would not write so big of a code that you were doing in the past, but 2 lines of a code, you know. So lot many things are given to the business users to make their work easier. So the mantra for Snowflake is ease of use and make any workload work on the system. You do not worry about the underlying infrastructure that you need to provision, but you should be focusing on the business value. Are the processes running in time? Is my data having lower latencies and at most freshness that the business needs at times? So focus on delivering value to the business rather than working with too many hurdles around the capacity, the contentions, or any other things that you would do for getting started. Now, data engineering is a big concept in itself. You know, it starts with data modeling. You can bring in your data model. Snowflake lets you bring and define any model, any architecture. I'm not going to go into too much detail because that becomes too technical, like Kappa, Lambda. A lot of architectures are available in the paradigm of how you should be setting up the strategy for your environment, be it data warehouse or data lake. But it does support any data type, whether your data is structured, unstructured, or semi-structured. When I say structured, it is like tables with rows and columns. Unstructured, you would be saying the logs, IoT logs, log files. And semi-structured is your JSON and XML structure. So it supports everything from get-go. So you need not to do too much pre-work to say, oh, the data has to be in this format. Whatever the data format is, bring in the data and you can quickly create these pipelines.
Correct. So as you said, each domain gets its own capacity, I mean, storage and resources in Snowflake, right?
They can get their own independent. We call that as workload isolation. So the concept of warehouses is like Snowflake offers warehouses in t-shirt sizes. You know, the t-shirt sizes comes in extra small, medium, large, going up to like 6XL. And depending upon the size of the warehouse, you would be obviously billed accordingly, right? Like how many credits. So it's like credit is like a token, you know, how many credits you will use if I were to run an extra small warehouse for the entire hour. And Snowflake bills you by seconds, not by like the calculation is by hour in this page, but they are actually billing you by seconds. So if you are running an extra small warehouse for 2 minutes, and then you suspend the warehouse because it is not processing any data, you're not billed for that time. You're only billed for the time it's gonna run the warehouse, or actually the queries are running and whatnot, right? On a warehouse. It's like not like you just created a warehouse and spun up the warehouse. We have some configurations that we have internally. When we create a warehouse, you can configure whether or not the warehouse should be auto suspended or auto resume to control cost. But it comes in t-shirt sizes, and then you configure depending upon the workload. So for an example, right? When I'm loading the data, I do not need larger warehouses. I would need a larger warehouses when I'm doing the data science model training, for example, right? Because they are memory intensive, they are CPU intensive. But when I'm loading the data, I may be good with a smaller or a medium warehouse, depending upon the type of data and the number of files we are loading from the source systems. But when I'm running my BI queries, I would rather choose somewhere between medium and large, depending upon the type of queries that are getting executed for consumption. So sourcing, transformation, supply, they can have their own independent warehouses because all these functions can run every time in parallel. They are not confined to use the same warehouse, you know, for workload isolation. And consider it from the impact analysis perspective, right? Your pipeline failed, and or your warehouse is busy. Why should any other business unit be blocked by that, right?
Exactly.
If your pipeline failed or you're doing something or you're loading too much data, your business still can continue on their own independent warehouse. They can still run their reports and whatnot, right? So the workload isolation also helps you define the level of impact. The blast radius can be controlled when things go wrong, right? So one service can be impacted if things go wrong, but other functions can continue.
Yeah, other will not get affected by
Yeah.
the. Okay. So in this course of big data, we are studying frameworks like Spark and Kafka. So how do you incorporate stream processing with these kind of frameworks?
Yeah, so if you talk about Snowflake, and again, I can talk in general also, let me know.
Yeah.
So we have things like streaming, you know. So we have an original concept called a snow pipe, as the word says, right? It's a pipe between two points, point A and point B, right? The pipe lets you bring the data into the environment of Snowflake from external places. Like you have your data sitting or getting generated from your machine, a machine data, or the data is coming and landing in S3, your external stage, we call as external location. So you can pair up and let Snowflake know that, hey, you're going to read the data from S3 buckets, or you're going to read the data from blob storage of Azure or GCP cloud, right? So you can create a pipe. The pipe lets you bring the data at a given frequency, which is at par at like a minute or so. But if you want near real-time ingestions, like you want less than 10-second latency on data that you want to bring, you would set up a structure. Like you would obviously set up a Kafka or a Flink for that matter, because these are certain things that will help you provide the data stream, flow of data between point A to point B. So in this case, if we take an example of Kafka, so we have a Kafka sync connector for Snowflake, which is using the SDK, which is a library. What Kafka would do is you in the Kafka configuration file, if you're aware, and let me know if I need to double click and, you know, bring it down. So in Kafka, you have a configuration file to say, what is Kafka gonna connect to? So you're gonna say, hey, go connect to Snowflake. This is a Snowflake account. This is the username. This is the warehouse. This is the database. And this is the table name or a topic name. And go publish the data and land the data into the Snowflake environment. So
Okay.
Kafka would play a role of creating something called as topics, which are
Mhm.
nothing but, say, consider a table for simplicity's sake,
Yeah.
right? So
Tables.
you have multiple topics in Kafka, similar to tables,
Mhm.
and then you have underneath offsets. Offsets means a point indicator, right? So you
Mhm.
have 20 files that you need to push from your source into Snowflake. Offset is an indicator saying how much data was processed so that you can replay if something goes wrong and you keep a track of the offset indicator moving as the data is getting processed from your source system into your destination, which is in this case Snowflake. So
Yeah.
Snowflake sync connector would help you bring the data into the environment so that you can start querying the data and make use of it.
Yes. Yeah.
It has
I
much more.
Yeah.
It
Yeah.
has schematics. You can define schematics like your normal Kafka data comes in JSON format.
Mhm.
So schematics can help you make it structured. Like it will define table with the columns that is, it is reading from the Kafka topic. So it can define those things. Normally this comes in a Java SDK. You have to have a Java code to do that. But once you install the sync connector as mentioned here in the diagram, Kafka sync connector, you can now provide Snowflake attributes, which are nothing but the Snowflake connection properties. So that Kafka can now write to Snowflake for that perspective.
We did try this Kafka and Spark in our like last homework.
Mhm.
We did all those configuration and all. We did it on the Reddit data for the
Okay.
sentiment analysis, like it's a small homework. But
Mhm.
whatever you're saying, like the offset and all, even our professor talked about it. It's great to know. Like you mentioned about Kafka, like how you are like you implementing Spark in your system ecosystem. Or...
So Spark is an independent component. We have Snowflake has its own, I wouldn't say version, but a comparable item that I can relate to in our discussion, which is called Snowpark. Snowpark is our way of saying running your data science or Python workload. So if you saw the previous page, Snowflake supports writing a code in Java, Scala, or Python. Scala, you are more familiar, right? When you talk about Spark, right? So if I want to use a Spark-like capability, Snowflake runs that thing using something called a Snowpark API, synonymous to Spark, right? Right? Snow Spark or Spark, right? Whatever you want to call it.
Yeah.
So Snowpark is a similar notion of saying running your Spark code within Snowflake. Now, let me talk about differences and let me go back to and talk about Spark, right? Then, so the difference between Snowpark API and Spark would be Spark needs its own JVM to run. It needs its own infra. It's an engine in itself. It will help you do the data ingestion and data transformation. But if you just take out the data ingestion piece from Spark, Snowpark can do the similar thing in much more cost-effective and performant way. And the reason for that is in Snowflake, using Snowpark, you can write Java code, Scala code, or Python code. It will do all the transformations for you within the environment because we are going to be using our warehouses to have a kind of a similar notion of you running a Spark with a JVM, but our warehouses are much more optimized on running that code for all the three data types or languages. So it's like meeting the data scientists and developers in the realm what they're familiar with. So Snowflake is not only a SQL running shop, right? It's not only that it will run SQL only, it will also run Java, Python, and Scala because of the Snowpark availability, which is all generally available in all the clouds that we support. Snowflake is cloud agnostic, by the way. It runs with Azure or AWS or GCP. So we support all the three bigger cloud service providers in the back. So Snowpark APIs is Snowflake answer to Spark, but in a much more performant and cost-effective way.
Okay. Thanks, Sunny.
Yeah. If you do a comparison between Snowpark and Spark and you don't see it, hold me accountable any day. But I can tell you, lot many our customers are building their entire data engineering pipelines. And when I talk about data engineering pipelines are built for business. They are more so conventionally built on SQL. Like a SQL code doing step A, step B, step C, and finally producing something for business that business can consume. Or it is built by data engineers and data scientists using the programming languages of their choice, which is Java, Python, or Scala, because not every data scientist is familiar on writing complex SQLs. They can write simple SQLs, they cannot write complex SQLs, but they're much more familiar with how they are going to use the programming languages that I'm highlighting using data frames, right? They are more proficient in writing Java code or a Python code. Now you can run the same code in Snowflake using the Snowflake infra, but without keeping all that noise of setting up the infra you would have to do when you are setting up Spark, right? You have to install a lot of things. You have to manage the compute nodes and cluster. Normally, you would get Java heap errors and other errors when you are running the Spark code, but not anymore because Snowflake takes away that all that burden and overhead from you. You just say, I'm going to use a warehouse for Snowpark and I'm going to run my Java, Python, or Scala code. As simple as that. You bring your code, you run it. You don't worry about the underlying infra. That's the whole concept.
That's great to hear because the Spark, they have the limitations in their 2 version. I think they are not supporting the Python in the PySpark. So
Yeah.
that's great to know that Snowpark is this.
Yeah. And by the way, Snowpark was built for cloud. So normally when you say PySpark and that kind of a trigger point, right? PySpark is something that is written on Spark in Python. So that adds a layer. So that lowers down your efficiencies when you're running scalable job. When you talk about scalability, right? The Spark can be scalable to some extent, right? You have to do lot many legwork, lot much engineering investment. Your resources have to be super skilled when you are talking about setting up the infrastructures and required to tune the knobs, right? You created a pipeline, you were processing 10,000 records. Now somebody comes in and say, hey, you were processing 10,000 records per day. Now you want to he has to process 10,000 records per second or per minute. How would you scale up your pipelines? You have to know the nitty-gritties of how the pipeline was built, how much time it is spending on each and every operation within the pipeline, and so many things. So you have to know about a lot of that stuff. I'm not saying you need not to know about writing efficient code. You have to still write an efficient code, but you have to now deal with much more in terms of how that code is actually getting executed on memory, on the resources, right? So it's a lot of work when you talk and deal with that knobs in the data engineering field, when you also have to manage not only your pipelines, but also the infra. So what Snowflake does best is, hey, let's take out infra first, let us give you the pre-configured environment. You pick and choose what you want, and you focus on writing efficient pipelines, right? So, and it will automate the execution of those pipelines in a much more efficient way because the engines which are going to execute your code have some intelligence, which is built in to the platform itself to give you that scalability and performance, So you can run your processes at scale with elasticity and serverless components in Snowflake. That's the whole mantra here, right? And it's not like a selling pitch, but something that our customers are actually using. I did share a LinkedIn blog about Fidelity. Fidelity is one of our bigger customers who are building their entire ML ops and all data pipelines, including models using Snowpark. So read about that. It's a like 5 minutes read, but a very insightful topic, how customers are using them.
We will read, Sunny. Thank you.
So, hi Sunny, I'm Saujanya. So, I would like to ask that while working, did you ever experience implementing the locality sensitivity hashing or any streaming algorithms in Snowflake? And can you share some of the use cases for that?
Yeah, hashing is needed. I don't know if you're talking about the hash component when you had to create the hashes for your data sets, right? Am I with you so
So
far?
the professor hasn't taken the topic yet, but we have a syllabus topic called like locality sensitive hashing algorithms, and there are like support streaming algorithms in the syllabus yet to come. So I wanted to know, like, have you come across implementing any algorithms or knowing any algorithms, or how you implement the locality sensitivity hashing?
Yeah, locality sensitivity normally comes when you are dealing with the global customers, right? Somebody running their things in like some other part of the world, in Japan or something. I don't know if I have it here, but uh, LLMs are getting introduced in Snowflake. We are talking about some ML powered functions, which will give you the capabilities of doing these, using large language models to do some translations, you know. So the localization would be kind of surfaced from translation capability in Snowflake, for that matter. So I've dealt with this, but this feature is kind of evolving. This is powered by LLM, large language models internally. Snowflake is supporting a lot of large language models, which is Mistral AI, Llama 2, BERT, to name a few, and much more in the upcoming days. From the hashing algorithm, I happened to use it once from the perspective of checking the skews, because lot many times when we build these hashes is for some performance optimization of some queries and some joins that we do across data sets. So I have used it, but not to a greater extent, because the use still gets limited from the cryptographic functions hashing point perspective, right? So they can generate some hashed values on the fly. As you say, they can generate a 64-bit hash value, but they're all pre-configured. It's not like something I have to do and make too much work. I would just call a hash function, and internally it will generate me the values that I can use for doing some analysis for skew data checks, that the data is kind of not just skewed on one side. Because what happens is when you are working on a big data, uh, you normally check for data distribution, because when, let me deep down a bit. The whole concept of MapReduce is, can I divide the work across number of worker nodes, right? So I have a problem statement. I divided the work on number of worker nodes, and then I'm gonna reduce it. So say whatever each worker node did, can I combine the results and produce the final output, right? Split, condense, and give the final output. Now, the hashing techniques, what we have used sometimes is to check for this queuing, because when we are running some workloads or pipelines, right, it's the longest pole in the tent, right? So in the sense that if I gave the job to 4 worker nodes and one of the worker node got too much data because the data was skewed. So I have a big table, the data is there by year, and I'm giving the data to all the worker nodes to process the data per year, as an example. And for one odd reason, the data for one particular year was like 20x as compared to other years, right? For some reason, that worker nodes will get super swamped with the amount of work they have to do. So they're gonna take much more longer. So we come across some scenarios where the customers do reach back in terms of saying that the jobs are running for longer and other strategies we have to put in place. So we do some analysis using hash aggregates to say what exactly is happening by checking the data distribution on those tables, or doing some comparisons. Like if I were to, so there's a concept of data clean rooms within Snowflake. So what it lets the marketers do from the data clean room perspective is two different parties or two different organizations sharing the data. But then you don't want to share sensitive information, right? So you would hash those values, right? I don't want to share the PII information available in one side of the organization or party A, and the party B needs some information. I would hash those values to know. Because I hashed it, I know what the output is gonna be with some salt, which is my way of saying my part of the encryption key using the hash and the salt as combined feature to de-identify my data, so that I'm not leaking my PII to the other party. So I can give them the data and get back the values and decode it back using the values that were generated. So limited use that we have for these scenarios. I don't know if I covered what you were looking for.
Uh,
Okay.
I have one small doubt, Sunny, if it's okay to
Mhm.
ask. So, professor was saying, like, obviously we're talking about the streaming, and that's the topic he's covering for the last week. So he said, like, in the large streaming data, like how we are like getting the data we need. And he was talking about like that's where like the streaming algorithms come in, like reservoir sampling, something like that. So how that's done in your environment, like, can you explain it like in simple terms or something, like how it happens in real time? The streaming data is coming in, like how we are getting the data you need for the dashboard or something.
So the streaming data is the same concept, right? We were talking about the Kafka. So the Kafka, with the our version of bringing the streaming data is Snowpipe streaming, right? It's an SDK that Snowflake provides on Kafka connector to let you ingest data in near real time with like less than 10 second latency. So I can pump in my data as it is happening or as the data is getting generated. All that data can be made available within Snowflake. Now, there is, however, a different concept, but I know you asked me about streaming. So our answer to streaming is Snowpipe streaming for near real-time data. But then there are other concepts if your data is batch mode, which is copy into, so you can periodically bring your data by running a copy into command into Snowflake. Now, if you want to access the data in place by not moving the data at all, Snowflake recently adopted an open table concept, which is called Iceberg.
Okay.
So Iceberg lets you access the data in place. You need not to bring the data into Snowflake for reasons that if you can't bring the data in, Iceberg is an open table standard format that will let you access the data as it is sitting in external location, keeping in check the performance. Performance is going to be at par with as if the data was within Snowflake environment. That's awesome.
Okay.
But if you were to ingest the data, we have those two options that I talked about, Snowpipe streaming or Snowpipe. Those are the two options that we would have. Snowpipe was our first take on bringing the data in a batch mode at a minute latency, I would say. Snowpipe streaming is much more lower latency, less than 10 seconds.
Okay. Okay. Thanks, Sunny.
Okay, so as the importance of data privacy is increasing, so can you tell like how does Snowflake ensure compliance with various data protection regulation?
Oh yeah, governance. So this topic is very, very much heart and center for Snowflake.
Hmm.
Uh, the first level of resistance for the longest time in the industry was, will my data be secure if I put it in the cloud? So somebody has to address the elephant in the room, correct? And I'm happy to say that got largely addressed with all the different levels of security that is now provided by cloud service providers, including Snowflake. We take security very seriously, right? Uh, the customer data has to be secured at all times. And when we talk about security, we're not talking about security of the data as it is stored, but data as it is in transit. So the concept of security starts with the authentication or authorization. So we support single sign-ons, your Okta integration, we support multi-factor authentication and whatnot, right? So you name it, from the concept of logging into the system, those are all there. Network policies. It controls which systems sitting outside Snowflake can talk to Snowflake, right? So I can block access to, say, if you are using your home computer, you cannot log to your office account, right? Because you have to be on the VPN, which is going to be within a certain set of IP ranges that Snowflake will accept as an incoming call or an incoming traffic, right? So we do a lot of those things as kind of checks when the data access is being requested. So we have network rules that are created. Then there are level of securities that are also provided by the cloud service providers. The VPCs, virtual private connections that can be made enabled made available, right? But if I go back to a point that you were saying, if the data is already within Snowflake, and then you want to make sure the data is meeting your InfoSec requirements in terms of SOC audits, that we normally say the compliance audits that needs to be put in place. So Snowflake provides column level security. what it would do is it will mask the data in the columns depending upon who is trying to access the data, right? So for example, you would create a policy and the policy would be enforced on the data. So if you have data, which is a phone number and SSN that is available in the table, when the masking policy is applied and you're not the authorized user to see that information, the policies will be enforced and the data will be masked. You may say that why I'm seeing the last four of the phone number, because it was set up that way. You control the logic and the rule that would say, do I want to show star, star, star? Do I want to show -9 or whatever you define? So you as the policy admins would define the policy condition and the masking function that you want to apply on the data. So this is done at the column level. The same thing can be done at the table level. Now I work for US and I am in a call center and I want to query something in a table, right? I should be only given access to query the information only for the US territory. My peer in EMEA will be able to see EMEA level information, but the table has data for the entire globe. If my manager or a super manager logs in, he may be able to see data for EMEA, for US, for APAC, LATAM, whatnot. So those things are controlled by the set of policies that can be applied. So you have data access policies that are available for data sensitivity and data visibility. We have features called as classification, which is nothing but tagging things. So you want to have access to the data. You want to apply certain tags for privacy, whether or not you want to say it's a PII or a non-PII. What is it, a sensitive information or not sensitive information? That information is a kind of made available to you to manage the classifications, right? From the policies perspective, you have something called as row access policies, I was saying, at the table level. So the table, again, a similar concept. Policy admin will create a policy and you can apply policy at the table level or a column level. And finally, to summarize that all, right, you have SOC reporting. You have something called as we call as access history. So you need to know and keep a track of who is accessing what, right, at all times. So there are compliance audits that you can run out of the box to say who accessed the data, when was the data accessed, what were the columns that were accessed, right? So the access history will give you and facilitate all the compliance audit that needs to be in place for you. Now, if I roll up all these things that are done at the granular level, what we do support is something called as RBAC, role-based access control. That is the most important thing that you would set up in Snowflake to have those access controls in place, which would say who should be able to see a database, a schema, or a tables or objects within that schema, right? So the security framework starts with RBAC and it goes down. So what we have a concept is called securable objects. You can secure warehouses, who can use the warehouse, who can see the database. You would define your roles and access level at different levels. So it can be a scenario where I am an analyst. I am given access to only a few tables to query, which are placed in a schema of a database, right? I may not be able to see everything.
Someone is at the front.
Yeah, okay, my door is buzzing, sorry. But you can have all these roles created, which will give you the level of granular access that can be made available onto the platform. Very critical because this will set up the path. What roles analysts should have, what roles business users should have, what roles the ETL developers should have, what controls you are giving on a table level. Are you only giving read access to a table? And within a table read access, what policies are defined on the table, and within the table, what policies are applied on the column level. And then you have access history to say, Sunny queried this HR table on this particular date by selecting these columns. So it is super critical to give the users the ability not only to secure the external boundary wall from the SSOs, integrations, network policies, network rules, VPC configuration, encryption of data in flight as the data is getting ingested, and the encryption of data as it is stored within Snowflake, but also very important to classify the PII and the critical information, and then create the role-based access controls to say who should be able to access what objects, and within those objects, the policies that would say, even if you have the access to the table, you're not going to you're not given or authorized to have access to the entire table data. You're only given a subset information. So all those things are very important, and at the heart and center of Snowflake, to give you the secure boundary in which the Snowflake operates, and users given the opportunity to define everything related to the PIIs, the RBAC, discretionary accesses, row access policies, and everything.
Okay.
So
Right.
in Snowflake, these kind of access rules, or you can say privileges, are predefined, right? Or admin need to customize each and every rule.
So you have to configure. You can create templates,
Okay.
right?
Someone was detected at your porch.
My door is busy, sorry, man.
No worries.
Yeah, so you can define templates, you can create a role, and the role serves as a template. Like a role would say, give the role access to database 1, database 3, all the schemas within those databases, because those databases belongs to finance. So there might be n number of databases in the system, but finance should access only finance related databases, right? Marketing should have access to their databases, right? But now there are collaborations, right? Finance needs access to sales, sales need access to marketing and whatnot. So you will not give them read-write access. So you would create a role which only permits them very limited use on those objects. So you would say only give usage access to some other team via a role on table, which is only a read-only table for them. But for your, if you are part of finance, you may have access to the read-write for access to the table. But if Priya is from other team, she may request access, but you will only give a read-only access. So roles help you create or bundle those kind of accesses in the privileges kind of a scheme of things, right? So you can easily define what level of access you would need, and then you would start creating roles. The roles are replayable. Like you can assign the same role to 10 users, right? You can assign the role to user 1, user 2, user 3. You can create a role of a role, and you can give access of one role to another role. You can create a hierarchy of roles also if you want. But that is something that the level of granularity should be defined at the customer level. And then there are best practices that needs to be followed. Like do not mucky up the water too much, right? Like role assigned to one role and another role assigned to another role. You should create hierarchies at times, like read only access role, write access role, and then there is a super access role which has access to read role and write role, you know? So you can create those hierarchies to help with you. So once that is created, whether you want to assign a read-only role to some user or give them write access, you decide it as an admin.
Okay. Yeah. Thank you.
Configuration is possible, yes.
Yeah.
And then we talk about end-to-end encryption, you know. Again, this goes into too much technical details, but Snowflake secures your environment end-to-end, you know. We run through a lot of SOC auditing, lot of certifications to make sure that your data or customer data is always protected from everywhere, from all means. It is encrypted. So you have encryption key management. So Snowflake has encryption keys, algorithms, you would say AES 256-bit encryption, and there are options for customers to bring in their own keys. So it's like so much encrypted that you have a root key. The root key is passed on to account master keys, which goes up to file level. So keys and keys and keys and keys. So the data is getting encrypted, over encrypted, and over encrypted, and so many things. And then there is tri-secret secure. Security is heart and center for what Snowflake does. So We have high trust certification. We comply with all these levels of certification that are the most difficult ones to get in one. And then we have HIPAA certification, if you are aware, the compliance for medicals and everything, right? HIPAA. So you
Yes,
have to have
actually,
HIPAA
our professor
compliance.
was talking about this,
Yeah.
giving an example of college and some details coming out about a student grade and something. So he has allocated like a couple of classes there to take these topics, but yeah, these are like very detailed explanation.
Oh yeah. So again, pause me if I'm going too deep or talking not or not answering your question directly.
No,
But
no, no. It
it,
was
it
great.
can go in multiple things. We have integrations with vaults that are provided.
Someone was detected at your porch.
My God. But yeah, you have customer managed keys from that you can bring in from AWS vaults, key management stores, right? From AWS or other CSPs that we support. So you can have that integration also for key management. So you can bring your custom key that can be combined with Snowflake key to create a super strong key. If some customers don't want to use only Snowflake managed keys and they want to bring their own keys, that is also possible. So it can go to n number of levels in terms of defining a super secure systems to how your data is going to be encrypted when it is stored in Snowflake. Right?
Yeah, thanks, Sunny.
Yeah.
Hi, Sunny. I would like to ask how do you see cloud data solution evolving in the next 5 years?
Oh, wow. It's all gonna be AI, LLMs. Uh, so we came a very long way. I was introduced for the very first time on Hadoop in 2008-9 time when somebody talked, oh, there's a concept called as Hadoop, and what does it does? Oh, you can store, petabytes amount of data in that environment. It will give you high availability. And we started learning about how Facebook back then, now Meta, was using to Hadoop systems to store all your, what do you call that, posts in Facebook. And then you remember different people friends with each other in a network. You refresh and you see different posts at different times. So if I made a post and you are all in my friend circle, you may not see that information all at the same time. Somebody refresh their Facebook might see first, somewhere somebody will see later, because we talked about eventual consistency, because the data was not stored in one data center for high availability. It was stored in multiple data centers because the storage was cheap, right? And Facebook kind of make use of it from the high availability standpoint, saying, I'm going to give you eventual consistency, because it doesn't matter if you saw the post at 656 or 658. It's not important, because eventually you will see it, right? But now we have evolved a lot of these things from that standpoint, because everybody wants everything within, like, not seconds but milliseconds or microseconds, right? So the requirements have evolved, so does the capabilities and the underlying infra. So a lot much emphasis was taken up from the Hadoop world into what was not letting Hadoop be successful for production deployments, production rollouts, or for creating data application, because it could not scale. It was just referred to as a cheap storage environment and nothing more. It was not meant to give you the elasticity and scalability that the cloud service providers are offering you. And AWS and Azure and GCP had come a very long way in terms of giving you all these services and the scalability and the resources. Now, things like Snowflake has given you a much more enriched experience to not worry about the infra also, because I can give you a lot of Lego pieces and say, hey, make a robot. Somebody may make one way of looking at the robot, and some robots can be ugly and some robots can be substandard or whatnot, right? Depending upon how you're configuring those Lego pieces and how you're making use of those Lego pieces. In the eventuality of things, you may say, yeah, I built a robot. It doesn't look too nice or too granular, as if a super expert in Lego pieces or Lego champion would build it. A super fine grade using a single dot, and creating a super awesome
Someone was
robot,
detected at your porch.
right? But somebody would make it a much more, or take a hack out of it, right? For that purpose. So it can vary depending upon the skill level of a person making use of those Lego pieces. Similar is a concept with these cloud service providers. They give you a lot of these services. You can make use of it in whatever way possible. Now, the developments that have happened within these services is also taking these services to the next level. Everybody now talks about the ease of use, how easy it is you are making use of these services, how interconnected these services have to be, and how performant and cost optimized services needs to be there, so that as your data is organically growing, and the data is the one thing that is going to continue to grow, whether you do work, not work, you are using electricity, you are using car, you are using insurance, everybody is collecting your data for every second. Believe it or not, right? You're using phone. The phone is generating telemetry. Apple is collecting data. They say they're secure, but nonetheless. So data is eventually gonna grow, right? Now, are there leaps and bound advancements that are done from the last decade to this decade in terms of how I can make use of the data? Yes. We are now entering into a new era where a lot of these heavy lifting that was otherwise needs to be manually configured and powered by making use of the skill resources in terms of making use of these large language models. All this work was happening. These large language models did exist part and parcel in some pocket organizations. Some were like little too under par, some were suboptimal, but exposing these out in terms of helping you with a daily set of activities is the way to go. Now, everybody jumped the gun when they talked about OpenAI, GPT 3.5 came in, GPT Turbo came in, Llama came in, now Mistral AI, and lot many things. These advancements are going to continue to happen. And where they're going to have an impact is on the repeated set of activities that was still not fully automated. Google started investing on Bard and now Gemini, and they're going to continue to make that investment. Everybody is now making a big bet on AI and LLM because they see value that this will help alleviate a lot of overburden.
Someone was detected at your porch.
This will help alleviate a lot of burden that people now have in terms of doing the manual chores that they are doing. Somebody needs to investigate a case ticket, right? Would they do and manually scrape through all the transcripts? No, they're gonna use these LLMs and the functions. I'm not saying only Snowflake, but LLMs to say, hey, can you give me the sentiment analysis? You can always write a AI ML model to do a sentiment analysis and do a lot of that work. But is that gonna be covering a lot of scenarios for a lot of industries? No. Now you have ready-made off-the-shelf things so that AI can be given to everybody without even knowing how to write the AI ML program. So to say, I can just call a function and don't care about anything that is happening, how that was built, because not everybody is an expert, right? Now business can make use of it. So it is gonna continue to move towards this AI hype, you would say. You say it's hype, but it's also FOMO, right? If you're not using it, you're missing it. So it's going to continue to have been powered in this momentum. And then I see that much more larger AI ML powered LLM models will come in the market, which is going to be more tailored towards specific industries, specific areas, and then much more enriched in terms of the things that we are talking about right now, the hallucination, like machine thinking something exists where it does not exist, right? But all those things will be kind of taken out, and these will be much more enriched and much more powered in terms of what the capabilities they can do. They're going to be at much more higher accuracy, I would say. Right now they are in uh, like upper 70s, if I'm not wrong, in terms of the accuracy or efficiency they are providing right now, but this is gonna hit upper 90s in coming days.
Yeah, we did explore all these AI concepts, and especially in data analytics, how they are generating the code and all in our first homework in big data actually. But
Hmm.
it's great to know this. This is going to evolve, and
Yeah,
yeah,
these are like AI on fingertips, I would say. We have done this. Like 5 years ago, we used to write propensity models, but it was a lot of legwork. That project would take 6 months to just uh, plan, analyze, collect data, massage data, write a program, check for accuracy, keep on rebuilding, and keep on improving the accuracies. Now that work from months will be shortened to days. This program already exists. You can just fine tune the model and you can deploy the code in production.
okay.
So it's a lot of time saving for the organization, and the value, and think about the value the business is going to get from these things. Lot many companies who cannot afford big data science teams, they can still make use of AI, right? They can still grow, they can still find these insights without doing and investing too much money
Yeah, that's
on getting powered by these things.
yeah. Thanks, Sunny.
Thank you, Sunny. This is Tanvi. I want to ask you a couple of questions.
Yeah.
So the first one is, can you describe a challenging problem that you've solved using Snowflake and what made its architecture particularly suited for that task?
Challenges are part of every day, Tanvi. It's never a dull day where you do not find yourself in a position where there is something that you need to research on or work on, right? Uh, there
Right.
are there are people problems, there are planning problems, there are uh, pipeline problems, environment problems. Those may vary, right? Any area of specific area that you want me to double click on?
So basically, what I meant was that something that is very specific to Snowflake, like a problem that you might have encountered that's very specific to Snowflake, and what made that problem unique with regards to Snowflake, and how you might have solved it. Um,
Uh, I'm just trying to pick up an example because we get things from product all the time. Like a product, say, if that will be too simple of an example. I ran a SQL and SQL failed, and it said, "Hey, system encountered an issue," but that will not add a value, right? Because you have to still work with the product to say what exactly went wrong. But let me give you an example from the design perspective. Customers implementing, they have their own perspective on things at times. They say they know Snowflake, they go out, start implementing those things by themselves without taking care into consideration the best practices, caveats, limitations. You say that, right? So there happened to be a scenario where Snowflake largely is analytical engine, right, powering your data warehouses. So that means it is not transactional in nature when you are creating certain objects within Snowflake. Now, when you are using the system from transactional capability, now we have a feature called as hybrid table, which is currently in public preview, giving you that feature saying, can I do very ultra low latency millisecond updates, inserts into the system? It's a preview feature, right? Prior to this capability, and I'm saying prior because this is still not GA, generally or globally available right now, but still with a select few customers who are making use of this and providing us the feedback. So this is not production ready, if I say that. But considering this, customer implemented a solution which required transactional capability because they run thousands of pipelines every day. And within the pipelines, they were maintaining something called as a job audit table to know that is the job running, so that if accidentally somebody reruns the same pipeline as a separate instance, it should not conflict, right? So I ran a job at 7. It is still running. Somebody accidentally tries to run the same job again, but the first instance of the job is already running. So they maintain some table to say, hey, if the job is already running, you cannot launch another instance of the same job, right? So that it doesn't steps over on to the previous run.
right.
So you have these kind of guardrails or gotchas that you build in these pipeline as part of your engineering, right? for managing the pipelines for dependencies and whatnot. So they have a table. Now that table is accessed by hundreds and thousands of jobs. And there happened to be a scenario where you start creating locks on that same table because lot many jobs are running. Lot many jobs wants to update the statuses for their specific runs of the jobs. The jobs are different. Job number 1, job number 2, job number 1000. They're all running at different times and trying to find a lock on the table so that I can lock the table, update my specific run ID job status in that particular table. Now you would say this problem is simple, right? But when you talk about how the data warehousing solutions are actually built, they are built for more for analytical purposes, where you are doing a lot of aggregates, you're doing a lot of reporting, rather than doing a very millisecond transactional capability to update these records. So prior to this feature getting rolled out, the transactional capabilities are very limited in Snowflake. So they built a solution which was not following the best practices that Snowflake would provide to our customers. So that resulted in a kind of a logjam. So it's like going to a DMV and they say, oh, I want to be serviced, but only one window is open at DMV. So everybody falls in a queue. When queuing happens, your job runtimes increases. If your job runtimes increases, your downstream pipelines are impacted because they are not kick-started because upstream job is still running, right? Dependency was not met. My downstream job cannot run. If the downstream jobs don't run, the consumption is impacted. Business do not see the latest and greatest data. So it's a ripple effect, correct? So we had to solve that locking problem. So we had to tell the customer that they have to change the design. You should not be updating your run ID table for each and every run that you are doing. Instead, always make an insert in that table. Now you would say for a specific run, I may have multiple entries. It's the same run of a particular job. I'm running a job for order table with a run ID 1001. I will make an entry into that table as 1001 run ID for order table as started, 1001 run ID for order tables in progress, and then finally completed or error entry. So I may have multiple entries in that table. So now the customer was concerned saying, I may get duplicate records when I search for the run ID. So we created a hash for that particular run ID and table as a unique value. And we use that hash value to make multiple entries into the table and then do a roll up check to say only give me the latest record for this run ID from the table when I'm inquiring whether my job completed or errored, right? So when a particular job instance is initiated, it will first check, do I have any instance of this job in running status or in progress status, right? So when we make that query, we go through that analytical view rather than making updates. We are now always making inserts. Now you can say that, hey, hybrid tables are coming. They're going to solve this problem. Yes, they're going to solve the problem, but this feature has to go to GA for the customers to use it because of compliance. So once this feature is GA, whatever I just discussed with you as a solution would have been a simple change otherwise. So say, instead of creating a regular Snowflake table, I would create a Snowflake hybrid table. And you know what was the difference if I were to create a hybrid table? Only this keyword. I would just do a create and replace table as a hybrid table keyword. And this will give me ultra low latency to do updates, inserts, or deletes in less than
Someone was detected at your porch.
in less than 100 milliseconds. So that would have solved customer problem, but this feature is not currently rolled out in production. So that's the whole reason. And that was a scenario that we handled with the customer. It eventually created an S1 at customer side because they didn't follow the best practices.
Okay, thank you. That was a really insightful answer. My final question to you is for students who are aspiring to enter the big data field, what learning paths or experiences would you recommend?
See, it all starts with hard work and then your passion to what you want to do. data is gonna be ruling the information technology for the upcoming time. If you are not into AI or not into data, it's gonna be a uphill battle. Whether you are gonna pick data engineering or business side of the world or any other thing, you have to interact with the data. So you're not gonna be at bay when it comes to understanding data. So you understanding what data means, what data products you want to create, how you can make use of your data to get this insights and business value, whether be an analyst, as an analyst, engineer, business user, or executive, you have to deal with it. Everybody talks about data. Then comes a point about technology and keeping an upbeat on things that are happening around. The world around us is changing at a very fast pace, as you know, right? From a last decade when we were all about Hadoop, now we're all about cloud computing, and new players are gonna enter the market. The market is only gonna heat up. Uh, Snowflake is there to help lot many things, giving you the cloud agnostic layers. You have your own independent cloud providers to give you a lot of that capability. It's only gonna mature from a perspective of how easy the solutions can be built and how can you cut short the time to market. You can build a fancy supersonic, ultrasonic set of aircrafts or rockets or whatnot, what Elon Musk is also building, right? But it is very important how you are building and how much time you are taking. So cost and performance and time to market are only going to be some not superficial words, but very critical to the success of any organization. So you have to think about building solutions which are not cost prohibitive, innovative, and are solving the real world problems. It can be a very small idea that can be converted to give you that richer insight and kind of that look and feel from perspective that it is making somebody's life easier, right? It has to be ease of use that has to be dealt with, the user experience, and what value it brings to the table that other solutions out in the market are not bringing back to the user community. So you have to think it through, basic scheme of things, but when you kind of bundle these things together, you have to make sure that you're not overcomplicating the situation at any times and keeping it simple. So if you keep those 4 mantras with you at all times and thinking through some innovation, it is going to give you a wonderful product at the end of the day. My boss used to say, fail fast, follow that approach, be iterative, and do not fear on trying out new things. It is okay to fail, but it is very important to fail quickly rather than just churning, and then be scared of the failure. I know it is hard to say. It is okay to fail. It is okay to fail fast, because that will give you an ability to churn, iterate over the thing, maybe go into another failure, but eventually you will crack it, right? So remember that thing. That's what I would say.
Thank you, Sunny.
Thank you, Sunny.
Thank you, Sunny.
Thank you,
Most of your
Sunny.
explanations we are able to connect directly to your to our syllabus and what our professor thought. And it was very detailed, and we were like able to know all the real time how it's configured. Thank you so much for all the detailed explanations.
Sure. I hope that was helpful. And if it is not, feel free to bug me again. That's totally fine.
No, it was really helpful. Thank you so much. Any other questions? Anyone on the team?
Not from my side.
Yeah. Okay. Thank you, Sunny. Thanks for joining this interview call.
Sure. Have a nice evening, guys.
Yeah. Thank you. You too.
Yeah.
Bye.
Thank you.